Okay, this is 5.4 quadratic word problem. So we're going to learn, or we're going to use what we learned the last couple of lessons and apply it to word problem situations. So what we talk about today, all of this is stuff we've already calculated. We already know how to do all of this. We just need to know what these words mean in a word problem situation. So we learned how to find the vertex. When you have the vertex, you have the x value, which we use that by calculating the axis of symmetry. The x value of the vertex, let's use a highlighter. The x value of the vertex tells you when the object is at the maximum height. The y value of the vertex tells you how high the object is at the maximum height. Then we talked about the y-intercept. We know that the y-intercept is when you have the c value. That's when x is 0, usually the c value. This tells you how high off the ground the object starts. The most important thing I want you to see there is that this is where the object starts. It's where, like if you're shooting a basketball, you're not standing on the ground. You're not laying on the ground to shoot the basketball, probably. You're standing up. So where it starts is not at ground level. But if you were shooting a rocket, that might actually start at ground level. So then it would start at 0. So depending on the situation, depends on where your y-intercept is and where the object that's being launched starts. You can also find how high something is after however many seconds. So let's say they give you a 2, then you would plug that 2 into the graph to find the equation. And it doesn't have to be 2, it can be whatever they give you. Then we need to talk about x-intercepts. On this, it's listed as zeros, but we also called them x-intercepts. We also called them solutions. We know that this is when you factor using trinomial, using the trident method, or using the quadratic formula, and you can find both of those solutions, both of those zeros, both of those x-intercepts. So let's look at this negative one. Usually we don't have the negative one because, like I said, that x-intercept is usually before where the height started. Now, in the case of a rocket being launched or something being launched from the ground, that should be at 0. Usually what we're looking for is the positive 0. So it tells us two possible things that can answer either question. When does the object hit the ground, or how long is the object in the air? Okay, let's look at this example. And I went ahead and numbered, so if you want to pause for a second and go ahead and number your graph, you can do that. A football is kicked with an initial velocity of 60 feet per second. The path of the football can be modeled by this equation. So let's think about the situation to begin with. This is a situation where the ball actually does start on the ground. So we kind of have an idea in our head of how this is going to look. I first want to point out that this doesn't have x and y, but that's okay. H could also be a y. The t's work the same way as the x's. So I don't want you to be concerned that we don't have x's and y's. H and t work the same way. I also want to point out that we don't have a number at the end, so you can always put your plus 0. That makes your A negative 16, your B 60, and your C 0. So we know axis of symmetry, x equals negative B over 2A. That's negative 60 over 2 times negative 16. And here's where you grab your handy dandy calculator and you put that information in your calculator to see what you get. So negative 60 divided by negative 32, which is 2 times 16, and we get 1.875. So we know that we can take that axis of symmetry over here, and at 1.875, which would be about right here, so we may need to spread our line out a little bit more here in a minute. So here's my axis of symmetry, and I don't know for sure how high we have to go. So we'll stop there. If we need to continue this on in a minute, we will. Okay, so then to find the vertex is where you take the equation, h equals negative 16t squared. Well, we just found t. We called it x up here. It's the same thing as t. 1.875 squared plus 60 times 1.875. Remember I told you if you can run your calculator well enough, you can just drop that whole equation right into the calculator, and hopefully it will give you the correct answer. So when I did that, I got the height at 56.25, which means our vertex is at 1.875 and the height is at 56.25. So now we can go to 56.25, which would be about right here, and we can put a dot. Now this is kind of just an approximation on the graph. Okay, the extreme value is the y of the vertex. We just found the y of the vertex, so the extreme value is 56.25, and let's look and see what this is talking about. Feet per second, so y would be feet. So let's actually label this feet per second. So now we've labeled our graph so we know what we're looking at. The y-intercept, we know that the y-intercept is the c, and in this case the c is 0. So we're going to put a dot right there for the y-intercept. That makes sense. We said that the football was probably kicked from the ground. So our initial height, or our y-intercept, is going to be on the ground where the football was kicked. So now let's get to some of our questions. So we've done most of our calculations. We may need to do a few more. We've done most of our calculations. Let's answer this question. How long will it take to reach the maximum height? Well, let's look at our graph. This is our maximum height right here. This is our vertex. And how long did it take us to get there? 1.875 seconds. So how long will it take us to reach the maximum height? That's really the x of the vertex. And in this case, it's 1.875 seconds. What is the maximum height? That's the same thing as the extreme value. This is the y. Whoops, that was crazy writing. This is the y of the vertex. It's the same thing as extreme value. So 56.25 feet. Now it says, how long will it take for this to hit the ground? We know this is our axis of symmetry, so it should be mirrored on the other side. So let's keep going here. 2.25, 2.50. We'll keep labeling. But to be certain that we've done this correctly, how long will it take to hit the ground? We are asking for the x-intercept. To get an x-intercept, we have to factor or use the quadratic formula. Well, in this situation, we had, let's go back up here and look at this equation. We had h equals negative 16t squared plus 60t. So we have 0 equals negative 16t squared plus 60t. This is GCF. So we can take out of both of these. We know that we can definitely take a t. What can we take out of 16? Let's see, there's 4 and 4, which is 2 and 2. So that's negative 2, 2, 2, 2, and t. So let's look at 60. Let's try 6 and 10, which is 2 and 3. And 10 is 2 and 5. So that's 2 times 2 times 3 times 5t. So what can we take out of both of them? 2 t's, or 2 2's, sorry, 2 2's and 1 t. There we go. So we have 4t, and in parentheses we have, don't forget the negative sign, negative 4t plus 3 times 5 is 15, and that equals 0. If it bothers you that the 0 is on that side, you can move the 0 to the other side. That's not a big deal. So now we separate each piece. So we take the first piece equal to 0, divide by 4, and t is 0. But guess what? We already knew that. We've already graphed that one right here. So we knew that the first one was 0. What we didn't know is we didn't know the second one. So the second one is negative 4t plus 15 equals 0. So we'll subtract 15 from both sides. So negative 4t equals negative 15. That doesn't go in there evenly, but that's okay. We've been working with decimals this whole time anyway. So 15 divided by 4 gives you 3.75. So t is equal to a positive 3.75. That tells me that the other x-intercept, let's change to pink, is 3.75. That looks like it's pretty balanced on both sides of the axis of symmetry. We actually, at this point in time, have enough to go ahead and draw in our graph. So let's draw in the path of our football. It would go up through here, come back down through there. The question is asking, what is the height after 1 second? So we can guesstimate. We can do our best guess here. So at 1, follow that path up. At 1, it's pretty close to between 35 and 40 feet. So to get the exact answer, we can take that 1 second, that's x equals 1. We can plug it into this equation. So the height equals negative 16 times 1 squared plus 60 times 1. So that's negative 16 plus 60, so that's 44. And you guys know my mental math, so we might want to check that to make sure that we're right. And I said it was between 35 and 40, so it looks like I undershot just a little bit, but that's probably how I drew my line. But at least I'm in the ballpark. So 44 feet. Now, this question's kind of an interesting one. It says, how long will it take the football to reach 44 feet? Now, we know the answer. We just found that. The answer is 1. But the reason I used 44 feet was so we could see how to work backwards. This means y is 44. So that means in the equation h equals negative 16t squared plus 60t, we know the y, or the h. We know this is 44. This means we would have to factor it again. We've already factored it, so we're going to have 44 equals 4t, parentheses, negative 4t plus 15. Oh, you know what? I didn't do that right. Erase. Put a little sad face there for a second. Okay, Let's try this again. 44 equals negative 16t squared plus 60t. We have to subtract 44 from both sides because I forgot the important rule of factoring. It has to equal 0. Negative 16t squared plus 60t minus 44. And I told you in class the other day that, so now we can take this, and now it's a happy face because we did it right. Okay. Once you have a negative right here, this tells you that we're going to use the quadratic formula. Quadratic formula. So, x equals negative b plus or minus the square root of b squared minus 4 times a times c. Oh no, I'm at the end. Over 2a. And you take this part, drop it into your calculator so we can see what we get. So negative 60 plus and minus. When we put that in our calculator, now remember the negative signs, minus signs are on the outside. Inside of the parentheses, that's when we get the negative signs. And if you're putting in your calculator and you're getting the wrong answer, check your negatives. That's 28 over negative 32. So we're going to have to take negative 60 plus 28 over negative 32 and negative 60 minus 28 over negative 32. Thought I was going to sneeze again, but I didn't. So x is 1. Oh dear. Okay. And x is 2.75. Well, we already knew that it would take 1 second to reach 44 feet. And let's look at the 2.75 right here. That's when it's coming back down. Look at that, pretty darn close. So going up, it's going to reach it. Coming back down, it's going to reach it again. So that makes sense. It's going to reach 44 feet 2 different times. Okay, so we're going to save the next one to do in class together, just so the notes will be kind of short. And we will practice some of these in class. We'll keep working on graphing and quadratic formula until we're good at it.